Salam alaikum. In this video we will solve the problem 916 from the textbook Fundamentals of Microelectronics. The problem states compute the output resistance of the circuits depicted in this figure. Assume all of the transistors they operate in saturation and GMRO is much higher than 1. So this is a condition. This is the condition of this problem. Okay, GMRO is much higher than 1. Okay, so I will give or explain the general idea or method to get the R out much quickly and efficiently method intuitive, which is much important. It is an intuitive method to get the R out from this type of circuits very quickly. So if we take this circuit, we can consider M1 as a resistance, okay, which is the RO, it's RO, okay, and we take M2 or the transistor which is linked with the output as the main transistor, and we can this is the P model of a degenerated common source, okay. So this is getting the its output impedance. I will just explain very quickly here. So this is the Vx, which is external voltage source, and Ix is through RO2 and GM2 VGS. So after this they will meet here, and the whole Ix will flow through RO1. So Vx and also VGS is VGS is minus the voltage through RO1, which is RO1 times Ix. Okay, so VGS is minus RO1 Ix. So the current here will be GM2 minus GM2 RO1 Ix. Okay. So after Vx is the voltage through RO2 plus the voltage through or not through, but the voltage drop through the two resistance. Okay, so Vx is RO2 times the current passing through it, which is Ix minus this value, which is minus GM2 RO1 Ix plus RO1 Ix. The voltage drop in RO1. After we will get this results, okay, and we will fill in the condition this problem, which is GMRO is much higher than 1, so we will be left of GM2 RO2 RO1. Okay, so this is the general idea of this, how to solve this problem. Okay, so we will go to the first circuit, which is this. Okay, so M2 is just a diode connected device. Okay, so its output resistance is just 1 over GM in parallel with RO. Okay, so RG is doing nothing because there is no current through the gate of M2. Okay, so it's nothing. Okay, so this circuit will be like this. Okay, so we will consider it like M1. So it's 1 over GM2 parallel with RO2. Okay, so this is what I mean. Okay, so R out is just GM1, which is the main transistors. Okay, GM1 times RO1 times the resistor, the degenerated resistor, which is 1 over GM2 in parallel with RO2. Okay, very simple, without doing the P model every time and T model or T model. It's just intuitive method to just get it very quickly. Okay, we will go to the second circuit. So this is the same thing. Okay, so we will not consider if it's the same VGS, there is no problem with this. Okay, it is so the out here is very easy, which is GM1 R1 same thing. This circuit will be like this, RO2. Okay, so this is M1. So GM1 RO1 RO2. Okay, this is very like simple. The third example. So here we have like how to say, like a small trick. Like here we will add the GMs, okay, and the resistance will still in parallel, and this is will stay R02, okay. So it will be like this. Out GM will be added to each other, like GM1 plus GM3 times the parallel resistor, which is RO1 parallel with RO3 times the resistor of the degenerated I mean like behaving as degenerated resistor, which is RO2. Okay. For the circuit D, it's better to do the P model, so we can get like a better vision of the circuit. So we have here the first transistor, which is it's called GM1, VGS1, and that is RO. This RO, which is RO1. The second transistor, which is GM2, VGS2. There is RO2 through it. Okay, so there is here a voltage source, which is Vx. Is here Ix. The VGS2 is between the ground and the output, so it's like VGS2. So VGS2 is obviously is equal to Vx. Okay. So we continue. VGS1 is. Oh, sorry. The drain is not linked with that. Yeah. So VGS1. Okay. So for VGS2 is Vx. So for VGS1 is minus the voltage through here. Okay. So the voltage through RO2. Okay. So the voltage through RO2 is like Ix. Okay. So we just write it, so it will become obvious. So it's minus, okay, because it's linked to the ground. So minus RO2 times the current passing through RO2, which is Ix. Okay, so is Ix minus this current. Okay, so this value. So Ix minus GM2 VGS2. Okay, and we say that VGS2 is Vx, so Vx. Okay, so we'll do so now the KVL of the. So the KVL is like the voltage drop through RO1 plus the voltage drop through RO2. So we write that KVL. Okay, so Vx is equal to the RO1 times the current passing through it, which is Ix, minus this value, okay, which is GM1. Okay, so for VGS1, yes, I have write it here, so we'll be replacing it. Okay, so we'll just write minus RO2 Ix plus RO2 GM2 Vx. Okay, also plus RO2, which is the current passing, which is like RO2, okay, times Ix minus GM2 Vx. Okay, so Vx is equal to the. So we're like distribute, so RO1 Ix minus RO1. So we also should be minus GM or just R01. No, so R01 GM1 or just minus GM1 RO2 IX. Yes, minus GM1 RO2 GM2 VX plus RO2 IX minus GM2 VX RO2. Okay, so now we will just bring the VX for the common. So wait, we'll just make another so it becomes more clear. Okay, so R01 IX plus R01 GM1 RO2 IX minus R01 GM1 RO2 GM2 VX plus RO2 IX minus RO2 GM2 VX. Okay, so VX when we break on to the VX up becomes R01 GM1 RO2 GM2 plus RO2 GM2. For IX it becomes RO1 plus R01 GM1 RO2 plus RO2. Okay, so VX over IX is RO1 1 plus GM1 RO2 plus RO2, and for the denominator is RO2 GM2, oh sorry, GM2 RO2 GM2 RO1 GM1 plus 1. So for the following the condition of the problem, so this is equal to the GM1 RO2 RO1 or GM1 RO1 RO2. Denominator is GM1 RO1 GM2 and RO2. So this is the results.